Okay, so today we're going to be talking about fractional distance and coordinates on a line segment. So this is why it's important that we be able to identify which one's x1 and which one's x2. Okay. So first, our definition of a line segment. Can anybody tell me what a line segment is? Part of a line. Very good. Part of a line containing two endpoints and all the points in between. Okay, then we have our one-dimensional coordinate system. So yesterday, at the very top of our notes, we filled in the blank. We said what was often referred to as a one-dimensional coordinate system? A line, right, a number line. So these are just going to be numbers used as locations of points on a number line. Numbers used as locations points on a number line. All right. And then last, we have fractional distance. So what does a fraction represent? What is a fraction? Yes. Right, it's a part of one whole, right? So this is just a portion or a part of a distance between 2 points. This scenario that says when an airplane is flying between major cities, the pilots are required to check in at certain intervals of the trip. This way, air traffic controllers can keep tabs on exactly where all aircraft are in the skies. If a pilot is required to check in when his or her plane's distance is at a ratio of 3 to 1 of the total flight distance, what is the total distance flown and at what will be the coordinate of the plane? See the map below to solve this problem. All right, so they have this map with this plane, okay? Now, before we can solve this problem, we're going to need to figure out what that 3 to 1 would mean as far as how much of the line or how much of the distance are they actually wanting us to go here, right? So, if you guys recognize this formula, this part was our distance formula from yesterday, right? The only thing they've added in front here is k, and k is your fractional distance. K is how much of the distance are you going to go? Are you going to go halfway, 3/4 of the way, 2/3 of the way, right? So that's where that comes in, okay? So k is going to represent your fraction, or they could write it as a decimal of how far or how much of the distance they're actually wanting you to go. And then just like yesterday, our x2 is still our ending point. And x1 is still our starting point. Okay, so then they give us a couple of examples here. Example A says to find 2/3 of the distance between the coordinates 12 and 33. So they went ahead and just came out and told us exactly how much we're going to go, right? So 2/3 would be my what letter from the formula? The K. And then my coordinates 12 and 33 would be our x1 and x2, right? Okay, so my fractional distance here is equal to K, which for us is good, times the absolute value of x2 minus x1, which for us would be, right, 33 minus 12. Okay. Now, your absolute value works just like you would treat a parenthesis or a bracket. You simplify what's inside first before you can take anything out. And we're not going to distribute 2/3 into it either, right? So we're going to take care of what's inside first, and then we'll take care of what's outside. So first, I'm going to subtract inside those absolute values. We've got 33 minus 12, which is going to give us, good. So I have 2/3 times the absolute value of 21. Well, the absolute value of 21 is just 21, right? You don't have to change its sign. So I can take that 21 out of the absolute value, and then I would just need to multiply those two terms together. So what is 2/3 times 21? 14. So 2/3 of the distance between these 2 points is 14 units. Okay? So again, they're asking you just how far you went here, right? So this one would still be positive at all times. Okay? All right, so example B, find the distance from 15 to 35 that has a ratio of 3:1. Okay, so this time they didn't give it to us already written as a fraction or decimal. We need to convert that into a fraction or decimal. Okay, so if I'm talking about this ratio they gave me, 3:1, how many parts total is 3:1? We got 3 parts here, 1 part here. Altogether, that would be 4 parts. Okay, so 3:1 has 4 parts or 4 segments. So 3:1, you're going to look at the first number, right? They said you're going to go 3 parts of the way there with 1 left over, basically, right? So 3:1 is going to mean we've gone 3 of the segments out of the total 4 segments. Okay, so the fraction here would be 3/4. What percent is 3/4? 75. And we know that we can rewrite a percent as the decimal. Correct. So you can write in your formula either the decimal or the fraction form where that K goes. Doesn't matter. They'll give you the same answer. Okay. All right. So now to find our fractional distance, it's equal to K, which for us is that 3/4, times the absolute value of what's our x2 minus x1? 35. Okay, and what is 35 minus 15? 20. And the absolute value of 20 is just 20. So 3/4 times 20 is 15. So 3/4 of the distance from 15 to 35 is 15 units. Okay? All right. So here, again, we're still just finding fractional distance, not an actual location, just how many units you would move to go that way. Okay? So let's flip it over onto the back. And here, we're going to talk about finding actual coordinate points. So a midpoint was a specific point on the number line, right? That's why we could have negatives. If they asked for the midpoint between -6 and -10, it was going to be -8 right in the middle. So here we can have negative answers because they're asking for a specific number on the line, not how far you went. Okay? So we're going to be finding the coordinate point that is some fractional distance on a line segment. And the formulas for the coordinate of fractional distance are these two right here. So this part is the exact same formula that we've been using, right? Okay. X1 plus means that on the number line, maybe you're at -1 and you're going here. That means you're going from this point to the 3, okay? If that is the scenario, if you're moving from left to right, in front of the formula, you're going to add this x1 plus, okay? But in this case, if you were going the opposite direction, so maybe they say you're going from 3 to the -1, in that case, you add an x1 minus out in front of the equation. So this is where it's going to be important you know your starts and end points. Okay? All right. So make sure that we pay close attention to which direction we're going. We're going to start doing a couple of these examples. So it says, find the coordinate of the point that is 60% of the distance from 105 to 136. Okay. So if I'm going from 105 to 136, did I go left to right or right to left? Left to right. Good. We increase in value there. Okay? So which one's x1, which one's x2? Very good. Make this one our x2, and then this 60% is our k, right? And I need to rewrite that as a fraction or a decimal. What is 60% as a decimal? Good. All right, so now we know all of the values that we need to plug in. All right, so left to right means we're going to use that top formula. That top formula says x1, which for us is 105, plus k, which for us, we said k was 0.6, times the absolute value of x2 minus x1. So 136 minus 105. Okay. Now again, remember, those absolute values work kind of like parentheses. We need to simplify what's inside of there first. So what is 136 minus 105? Okay. So I have 105 plus 0.6 times the absolute value of 31. And the absolute value of 31 is just 31. So I'm just going to go ahead and drop those absolute values. All right, so now I have 105 plus 0.6 times 31. So order of operations says I'm going to do what first here? Multiply. So what is 0.6 times 31? 18.6. Very good. So I have 105 plus 18.6. And 105 plus 18.6 is? Very good. Okay, and this is a location, right? We aren't saying that we moved 123.6 units. We're saying we want to be at 123.6 on the number line. Okay? So this is a specific place, not how much you moved. All right, so let's look at example B. All right, example B says find the coordinates of the point that divides the line segment below into a ratio of 2 to 3. Okay. They did not express to us which way we were going. So remember what I said yesterday. We would assume in that case that we must be moving from left to right. So this is my x1, and this is my x2. Okay? All right. Again, they gave it to us as a ratio. 2 to 3 is going to have how many parts? 5. Good. 5 parts. So the ratio 2 to 3 would be what as a fraction? 2 over 5. Or if you wanted to turn that into a decimal, what would that be? 0.4. Okay, you can use either one as your K. All right. Since they didn't specify, if again, you guys remember, if you happen to flip the order here, it should be okay as well. But since they didn't specify, we always assume left to right. So we're going to have our x1 at negative 13. Since we're going left to right, that's the top formula, so the plus sign goes here. And then 0.4, okay, times the absolute value of x2 minus x1. So I'm going to have 17 minus negative 13, right? Well, we know that two negatives there really are going to make it positive. So really inside of here we got 17 plus 13, which is going to be 30. Okay, so we got negative 13 plus 0.4, and the absolute value of 30 is just 30 times 30 there. All right, and what is 0.4 times 30? Good. So I got negative 13 plus 12, which is negative 1. So if I was to go 2/5 of the distance from x1 to x2, I would land on the point negative 1. All right? Okay, so now back to that airplane problem that they referenced earlier in the notes. It says, how far will the plane have traveled and what will its coordinates be when the pilot must call the air traffic controller? Yeah, the ratio was 3 to 1. So the ratio 3 to 1 is what fraction? 3/4, right? 3 to 1. So the 3 was the first thing mentioned, so that's what's going to go on the top of your fraction. So 3/4 or 0.75, whichever you prefer to use. Okay. So for my fractional distance here, I'm going to have 0.75 or 3/4 as my K times the absolute value of my x2 minus x1. So 746 minus 138. All right. Okay. So for inside my absolute value, what is 746 minus 138? Good. And the absolute value of 608 is just 608, right? And what is 0.5 times 608? Good. So the distance they will have traveled is 456 miles. If they want to know the exact location that they're going to land at, then we would use our second formula for coordinate, right? So for our coordinates, it's going to be the exact same formula, but we need to put our x1 in front with a plus, right? Because we were moving this direction. So our x1 in this case was the 138 plus all of this. Right? Well, we just did the math for all of that part, and we said that it became 456. So I'll have 138 plus 456, which is good. So if they wanted to know where you would be after you've gone your 3/4 of the way, you would be at the point 594 on that number line. Okay? So that's the difference between our formulas. This tells you how far you've gone. This tells you where you're at. Okay? So that's why this one can be negative, this one can't. Right? Distance is never negative, but depending on where you start or stop, you could be at a negative coordinate point. Okay? All right.